This section is on factoring using GCF. So this is simply the distributive property, but backward. And the beauty of this is that you can always check your work by taking the factored answer and then using distributive property to see if it's correct. So the first thing you're going to look at is this 3x plus 9. So what you want to say is there a common factor, the greatest common factor between 3 and 9? And it is. There's a 3. So you can take the 3 out, and then you put the parentheses there. This is starting to look like distributive property. So you'll say 3 times what will get me to 3x? Well, that's x. And then you're going to say 3 times what would get me to 9? And that would be 3. So your answer is 3 parentheses x plus 3. You can always check it by saying 3 times x is 3x. 3 times 3 is 9. So this is what we're shooting for. 3 parentheses x plus 3. Let's go over to 2x plus 8. Greatest common factor with 2 and 8 is 2. 2 times what is x? Or 2x, so it's x. 2 times what is 8 is 4. And you can check it. 2 times x is 2x. 2 times 4 is 8. 4x minus 12. Greatest common factor is 4. 4 times x will get you to 4x. 4 times negative 3 will get you to negative 12. Be careful here. Let's double check it. 4 times x is 4x. 4 times negative 3 is negative 12. 3x minus 12. Greatest common factor is 3. 3 times x will get you to 3x. 3 times negative 4 will get you to negative 12. 3x minus 12. Now let's look at 2x squared plus 2x. Got a greatest common factor of 2. But before we put that parentheses up, we've got an x squared and an x. Remember, when you have exponents and the bases are the same, we're going to pick the smallest exponent value, which would be x. So 2x is the greatest common factor, greatest common monomial factor of 2x squared and 2x. So now we have to say 2x times what will get me to x squared? And that's just going to be a plain x. 2x times x is 2x squared. 2x times what will get me to positive 2x? And that's just going to be a 1. You can check it. 2x times x is 2x squared. 2x times 1 is 2x. X squared plus 4x. We have an x here. That's the greatest common monomial factor. X times x will give me x squared. And x times 4 will give me 4x. So you can pause the computer, try these last 4 on your own, and I'll have the answers up. And there are the final answers for these 4. Now let's take a look at this next section. These are a little harder. We have 3 terms here. We have a trinomial. We have 10y cubed plus 20y squared minus 5y. So let's look at the 10, the 20, and the negative 5. What's the greatest common factor here? It would be a 5. Now we have a y cubed, a y squared, and a y. Remembering, when we have the same bases, you're going to go for the smallest exponent value, which is that 5y. So we're going to take this into 2 steps. 5 times what is 10? 2. Y times what is y cubed? Y squared. 5 times what is 20? Would be 4. y times what is y squared, which would be y. 5 times what would give me negative 5, negative 1, and then you already have the y there. It's not a bad idea just to go back and just check. 5 times 2 is 10. Y times y squared is y cubed. 5 times 4 is 20. Y times y is y squared. 5 times negative 1 is negative 5, and just bring that y along. This is why it's important for us to make sure that we understand our rules with multiplying with these exponents. Now this problem over here to the right is an interesting one because we have a negative 12, and we have a negative x squared. It's not written in standard form, but we'll still go ahead and solve it. What I like to do is I like to take out as the greatest common factor a negative. And the reason is that when we start working with factoring down the road, it's just going to be a little bit easier if we get that negative 1 or that negative anything out of the way. So in this problem here, the greatest common factor of negative 12 and negative 8 would be negative 4. And then with x and x squared, it would be x. So now we have negative 4 times what would give me negative 12, and that's just a positive 3. We already have the x, so we don't need anything else. Negative 4 times what would get me to negative 8, and that's just going to be a plus 2. X times x would give you the x squared. So I'm just going to double check. Negative 4 times 3 is negative 12. There's your x. Negative 4 times 2 is negative 8. X times x is x squared. Last problem's down here. We have 2x squared y minus 6x squared y. So we have the greatest common factor with the 2 and the 6 would just be the 2. Smallest exponent value with the x and the x squared is x. Y squared and y would give me y. And we have a 2. We don't need a number here. You could put a 1 if that made you feel more comfortable. We already have the x. You need another y. Minus 3. And you need an x, and you already have the y. So some of you may be saying, well, there's a negative right here. Why didn't we take out a negative? And the reason that we didn't take out the negative in this problem is because it wasn't in the front. It's not with that leading coefficient like we had right over here and here. If we just had one of them, it still would have worked. It still would have taken out the negative, but we'll do more of those practice ones later. So like down here, we have negative 15x to the 6th y minus 3x squared. So I'm going to go ahead and take out a negative 3x squared. I have a y on the first term, but I don't have a y in the second, so I can't take anything out. Negative 3 times 5 will give me negative 15. X to the 4th. We got to take that y along. And this would just be plus 1. Now these are a little bit different. So this is kicking it up a notch. So let's take a look at this first problem right here. We have 7 parentheses x minus 3 minus 2x parentheses x minus 3. Do you notice anything with this problem? Anything that you see? Well, you might have noticed that these are common. So in a sense, we already have a common factor. X minus 3. Go ahead and take that out. What's left over? We have a 7 minus 2x. Does it matter if we do this? No. Either one. Let's go over here to the right. What do we have common? We have these x plus 2's. I'm going to write that once. And then we have negative 4 plus 5y. The page is moving. Okay. Down here we have x squared plus 4 is common. I have a negative x. I don't have anything over here. What do you think is going to be there if you don't see it? It's just simply a plus 1. Put a 1 right there. Now in this problem here, I have an x plus 4 and a 4 plus x. Commutative property allows that to happen. I always write the x plus 4 or the x first because we'll be using this more often. Now, this technically isn't completely factored. We would have to go and redo that, but I'm going to save that for another time. I have an x plus 7 and an x plus 5. This is it. This is done. We can't do anything with this because we're not going to string everything together. This is fully factored. So now here, this is factoring by grouping first. So I have a polynomial here, 12a cubed minus 9a squared plus 20a minus 15. And what I'm going to do is I'm going to group them so I can make them look like these up here. So I'm going to put parentheses around the 12a cubed and the 9a squared, and then the 20a and the 15. And then I'm going to say, well, the 12 and the 9 has a 3. A squared and a cubed is giving me a 3a squared. Then I'm left with 4a minus 3. Over here, if I pull a 5 out, I'm left with 4a minus 3. So I have 4a minus 3, and then my 3a squared plus 5 is where I'm going to do my final answer. So down at the bottom is one we can try. It's 9x cubed plus 18x squared plus x plus 2. So I'm going to do this off to the side here. I'm going to say 9x cubed plus 18x squared plus x plus 2. If I take out a 9x, I'm left with x plus 2 plus x plus 2. Remembering that I have a 1 right there, my final answer would be 9x plus 1, x plus 2. So that's it for factoring using GCF. Check the website for homework if you have any.